There's a region of our planet that no human being has ever visited. No one has ever seen this place. Yet what happens here affects every one of us, every day of our lives. It's 2,000 miles beneath our feet. The Earth's molten core. Here, a vast ocean of liquid iron generates an invisible force. The Earth's magnetic field. It's what makes our compasses point north. But it does a lot more. It helps to keep the Earth a living planet. Our neighbors, Venus and Mars, have only weak magnetic fields, which means they're unprotected from the deadly radiation sweeping through the solar system. The Earth, on the other hand, exists within a vast magnetic cocoon. A force field that for billions of years has sheltered us on our journey through space. The magnetic field is created deep in the Earth's core. It streams out near the South Pole, loops around the planet, and then runs back into the core near the North Magnetic Pole. This is the Earth's protective force field. Without it, we'd be in trouble. Space weather is nasty. The winds that blow through the galaxy are winds of radiation. Some of the most harmful from distant exploding stars.
But there is another source which is much nearer, which is our Sun. The Sun itself is a thermonuclear furnace, and this flings off huge amounts of dangerous material in very large explosions.
Every few hours, the Sun ejects billions of tons of electrically charged particles, the solar wind. Often, the Earth lies directly in the path of this onslaught. But magnetism deflects charged particles. This means that the solar wind is unable to penetrate the Earth's magnetic shield, and so flows harmlessly around the planet. The only visible signs of this drama far above our heads are the northern and southern lights, produced when solar particles trapped in the Earth's magnetic field are dragged through the atmosphere toward the poles.
On Arctic nights, the aurora often flames across the winter sky. What is it, and where does it come from? This is where the tale of the aurora starts, on the Sun, a star of average size among billions of other stars in our Milky Way. The Sun acts as an enormous power plant. The energy is created deep inside the core of the Sun. Here the temperature is over 14 million degrees, and the pressure so enormous that hydrogen atoms are squeezed together into another element, helium. This nuclear reaction releases energy. The light radiates outward from the core of the Sun. In the outer layers, the heat moves to the surface in huge eddies called convection cells. These electrical currents of charged gas create magnetic fields inside the Sun. In some places, strong magnetic fields push their way up through the surface. They slow down the eddies of hot gas. The surface cools, and darker sunspots appear. The electrically charged gas is called plasma. The plasma drags the magnetic field further outwards. The magnetic field stretches and twists like a rubber band. And then the rubber band breaks. Several billion tons of plasma is hurled out from the sun. This is called a solar storm. The solar storm can reach speeds over 8 million kilometers an hour. After 6 hours, it blows past the planet Mercury. After 12 hours, the planet Venus. And after 18 hours, the solar storm reaches Earth. When the solar storm reaches our planet, something strange happens. An invisible shield, the Earth's magnetic field, deflects the storm. The magnetic fields couple together and create a funnel where the gas streams down on the daylight side of the pole. This is the daylight aurora. The magnetic fields stretch further back and couple together. The magnetic rubber band breaks, and gas from the solar storm streams along the magnetic lines towards the poles on the night side. This is the nighttime aurora.